Hello there and welcome. In this lesson, we're going to learn about loops. Loops allow us to repeat a block of code multiple times instead of writing it manually. So each time you hear the word loop, think about repeating something. For example, we can always just print a number and then duplicate it. And this will be totally fine, but sometimes we will have to print it hundreds or thousands of times, so obviously we will not do this manually. We don't even know the values, sometimes the values will change, so doing this by ourselves is not efficient, and that's why we want loops. And there are different types of loops, and each type of loop is used in different situations. The first kind of loop is a for loop. We use this for loop when we know the exact amount of times we need to loop. So maybe we want to have some kind of counter, maybe we want to have some kind of countdown, maybe we want to just print something a certain amount of times. For this, we use the for loop. Now, the for loop can be a bit confusing because of the way it looks, but after you do this a few times, you're going to understand. To create a for loop, we're simply typing the for word, and we're going to have these parentheses like in the if statement and brackets for the code. So this is the block of code that will be executed each time, okay? This loop will run the code several times, and if I write something inside, it will basically write it over again. So for example, we want to write or print number something. Now, the way it works is that we provide some kind of counter, some kind of integer, and we increase this counter each time we loop. And then we also have a condition that will check if it's the time to stop looping. So the way it goes is usually we have an integer and we use the letter I. So think about it as index or something like that. You can also use C as counter. The letter doesn't really matter, the variable, you can use whatever you want. You don't have to use one character, you can use a full word. It doesn't matter, it's a variable and you can give it any name that you want. But usually you're going to see something like that. You're going to see this I equals 1, for example. So we start our counter at 1. Then we're going to have this semicolon that basically separates this part. And you can already see the auto-completion. So the next part, we're going to have a condition. So as long as I is smaller or equals 5, for example, so this is the condition. As long as our counter is smaller or equals 5, you're going to continue looping. Then we have the last part, which is increasing the actual counter, and we saw this operator. This basically means increasing it by 1. So if I write this small comment here, we have our counter, we have our condition, and we have our, or let's say, change. So this can also be something else. We can reduce it each loop. Maybe we have a counter that goes down, so maybe a countdown. So we need to reduce the counter. So it really depends on what you're trying to do. But think about this as 3 different parts. We have the actual counter, we have the condition, and we have the change that we're about to do. So remember, the code goes line after line. It will basically start here. Maybe we have some more code at the top. It will reach this for loop, and then it will basically start checking this entire thing. First of all, it will check the counter and it will see, okay, I is 1. So the value of the counter is 1. Then it will check the condition. As long as I is smaller than 5, continue looping. So it will know, okay, I need to loop at least once. Then it will increase I by 1. So it means that after this loop, I will be 2. And then it will loop once and it will run this code. And imagine we're going to see this printed. Now, it will end this loop and it will come back here because it's a loop. And then it will check again, but this time I will not be 1, it will be 2. Because we increased it over here. And then it will check the condition again. But I is still smaller than 5, right? Because even though it increased to 2, it is still smaller than 5. So it will know, okay, I need to loop again. And then we're going to increase it again. So it will loop this again, and we're going to have a second print. Then it will return again, and it will look at this, and this will be 3 this time. So it will basically check if I is smaller than 5. Yes, it is still smaller than 5. Then we're going to increase it, and we're going to print it again. And then it's going to come back. It will check it is still smaller than 5. Then it's going to increase it, and it's going to print again. And then it's going to come back here, and this time it's still smaller or equals 5, so it will still loop, and it will increase. So it's going to print this again. But then it will come back here, and it will see that I is 6 now, and 6 is not smaller or equals 5. So it will not increase the counter anymore, and it will not print anything anymore, and it will basically end the loop, and it will continue with the code. But we are going to see these 5 prints, and this is basically the way this for loop is working. It has a counter, it has a condition that will check when the loop should stop, and we can also increase or decrease the counter. Now, why is the for loop useful? It's because we can actually use this counter for different things. Maybe we have some kind of list and we want to go over the different elements inside the list. We're going to talk about lists later. Maybe we want to print these numbers, right? Because at this point we did not print these numbers. But if we take this I over here, this variable, and we print it, it will basically print the value each time, right? First it will print 1, then the next time it will be increased, so it will print 2, it will print 3, 4, 5. So we can actually use this integer, this variable I, inside of our actual code and do different things with it. Because if I run it right now, of course, this is just comments, but if I run this right now, we can see number 1, number 2, 3, 4, 5. Now, of course, if I'm going to increase this to 10, then it's going to loop 10 times because the condition will only be met on the 11th time when I will be 11. Only then the loop will break. So if I set 10 over here, it will loop 10 times, and you can see that it printed the code 10 times. So it's a way to repeat the code, and obviously we can have more complex code. Maybe we have some kind of, I don't know, anything that you want to repeat, and this way you can control the amount of times it will repeat. So you can use this when you want to repeat something a certain amount of times and you know the amount of times you want to repeat it. Now, of course, we learned conditional logic in the previous episode, and you can use it together. Usually when we loop over something, we want to also check something, we want to run other code, so you can always have an if statement inside and check something. Maybe you're looping over some kind of number, and then you want to check if I is bigger than 3. So it will loop and it will always check if I is bigger than 3. Console write line. We are going to loop over all of these numbers, over 10 numbers, and each time it will execute this code. It will basically repeat the code, but each time this I will be different. The first time I will be 1. And then it's going to check, is I bigger than 3? No, it's not. So it will not print this code. Then it's going to continue. It's going to increase I by 1, so I will be 2. Then it's going to check again. No, it's still not bigger than 3. Then it's going to ignore this and loop again. It will increase it to 3. Is 3 bigger than 3? No, it's still not bigger. Then it's going to ignore this again. It's going to start a new loop. And then it's going to be 4. And this time, it's going to be bigger than 3, so it will print 4 is greater than 3. Then it's going to continue to the next loop, 5, and 5 is also bigger than 3, and it's going to say 5 is greater than 3, and it will continue up to 10, and we can see it if we run. So it basically ignored the first loops, right? As long as it was smaller than 3, it ignored it, but then 4 is greater than 3, 5 is greater, 6 is greater, 7 is greater, until 10, and then it basically met the condition and stopped the entire loop. So we can have loops and we can have conditional logic inside of these loops to check different things. We can actually check and use this counter to do different things. Maybe we want to check a specific thing. Maybe we have some kind of countdown and we want to check if we reached some kind of number. So there's a lot of different things we can do with this. But the point is that this for loop is used when we have a predefined number of loops. Now, the second type of loop is a while loop. A while loop is just a loop that will repeat until a condition is false. So we talked about conditions in the previous lesson, that we can have conditional logic and have some kind of condition. And if the condition is true, then the code will be executed. So with this while loop, we basically type in while and we have these parentheses for the condition. And we can basically check if the condition is no longer true. So if the condition is true, it will continue looping. But if the condition is false, then it will stop looping. Okay, so you can remember that while stands for loop while condition is true. While, or as long as the condition is true. And it can be any condition. We can use expressions, we can use bools, int countdown 5. As long as countdown is bigger than 5, loop, okay? So it will always check if the countdown is bigger than 5, and we can print something. We can even print this variable by itself, and it will simply show the number. But then, after each loop, we can decrease the countdown. So remember, this thing over here is exactly like doing this, minus equals 1. We simply take 1 out of this number, so we decrease it. It will be 4, and then it's going to be 3, it's going to be 2, 1, 0, and if we don't stop it, it will go to minus 1, minus 2. But this is the same as doing minus minus. So what will happen here? It will start the program, it will see that the variable is 5, and then we're going to get into this loop, and it's going to loop, it's going to repeat this code as long as this condition is true. So countdown is bigger than 5. No, it's not bigger than 5, right? Because countdown is 5, and 5 is not bigger than 5, so it will not even run this one time, right? In our example, this won't even happen. It will basically skip this entire loop. But if we change this to 0, then it will start actually looping, because this will be 5 and 5 is bigger than 0, so this is true. And it's going to loop, it's going to print the countdown, which will be 5. And basically at this point it's going to be 5. But then it's going to decrease it by 1, so it's going to decrease it to be 4. And this entire countdown will be 4 at this point. And it's going to go back here because it's a loop. And it's going to check, is countdown bigger than 0? And yes, at this point, it's going to be 4. And 4 is still bigger than 0. So it's going to print the code again, right? It's going to loop again. And this time, it's going to print 4. And it's going to decrease it to 3. And then it's going to come back here. It's going to check again. Is it still bigger than 0? Yes. 3 is bigger than 0. So it will print this again. And it's going to continue with these loops until the number reaches 0. And when it reaches 0, countdown is not bigger than 0 because 0 is not bigger than 0. So it will stop this loop and it will continue. So it will do this and it will do this, but it will never actually print 0 because at this point, the loop will stop. And we can see this. 5, 4, 3, 2, 1, and the loop was ended. Of course, we can also print something here. You can see 5, 4, 3, 2, 1, loop was ended. Obviously, we can make the countdown even bigger, 100. And now if we run this, it's going to loop 100 times. Now we can do something crazy and loop 1,000 or 10,000, but I advise you not to do it because your program will simply be stuck until all of these numbers are going to be printed. So don't do this. If you don't have enough resources, your computer can even crash. So we don't want to have a very big number, but if we do 100, it should be fine. And it was actually pretty fast, but you can see it printed all of these numbers. So that's the point of the while loop. Now I show you all of these examples just so you understand what is the use of each kind of loop, but of course, things can get much more complicated. You can do crazy things inside. You can use loops inside of loops. You can do many other more complicated things, but you don't need to worry about this right now. We're just going to understand what is the point of each kind of loop. So we have for loops that are used when we know the amount of times to repeat. We have while loops that we use when we want to check a certain condition, because this is a counter, but it can also be some kind of bool. And then it's just going to check this bool. While is online, print something. Maybe, I don't know. You are online. Obviously, there's no point to print this every second, right? Because it will simply print this as long as he's online. But if sometime during the code this will change to false, then this loop will basically stop. And it will stop doing this and it will continue. Because as long as this is true, the code will not continue to the next lines. It will still be stuck here inside of this while loop. So again, we can do different things with these kinds of loops. The next type of loop is a loop that is not used a lot. I still want to show you, but just know that it's something that we usually don't really use, at least not in most cases, maybe in very specific situations. And I'm talking about the do-while loop. A do-while loop can be used when we want to run some code at least once and only then start checking the condition. So in a while loop, we check the condition each time, and if the condition is not true, then it's simply not going to print anything. But with this do-while loop, we are going to print something once, and only then we're going to start checking the condition. So the way the do-while loop looks like is do. We have this bracket of code, and then we have while and the condition. So the condition comes at the end of the block, and we can print something like console write line. Then it's basically going to ask the user to enter the password, but we need to do this at least once. Even if the user is going to provide the correct answer, we still want to print this at least once, right? So with the while loop, if the password was correct, it would simply stop the loop. So with the do while, we are going to run this code once, and then we're going to start checking the condition. So we can use something to store the password. Say we have this string password, and let's say it's empty at first. And then we're going to set the value of the string using something called console readline. And readline is something that comes with Visual Studio as part of C#. It basically allows us to input some data into the console. So we still did not use this, but this is a way the user can interact. Obviously, in a real program, the user is not just going to input data into the console. He's going to have some kind of visual interface, some kind of UI, some kind of input box, right? But this is just an example so you can see how this do while loop is working. And then after the user is going to input the data, this password will contain the data that the user has inputted, and then we can check if the password is not equals 1234, because this will basically be the password. And if the password is something else, it's going to ask him again, and then it's going to provide something again, and it's going to check. If the password is not this, it's going to ask him again. So we can see this, and only if the password is 1234, then it's going to break out of this loop, and it's going to continue here, and it's going to say access granted. So now we can run this, and then it will ask enter your password. And because we use this console read line, we can actually provide some data here. So if I provide something that is not the password, for example 777, and I press enter, it's simply going to ask me this again, because this was not the password, this was not true, or actually it was true, right? It was not. Remember that this operator means that it is not. So if we want to check if it is the password, we can do something like this. We can see if the password is equals 1234. But then the while loop is not going to make any sense. So we want to check if it's not the password, then repeat the loop. And of course, if I do 1234, then it's going to break the loop, and it's going to tell us access granted. Again, we are not using this do while too much, but just know that if you ever see something like this, this is the way it works. It will first loop once, and then it's going to check the condition. And if the condition is true, it will loop again. As long as it's true, it's going to keep looping. And only when this is false, it's going to break the loop, and it will continue. The next type of loop we're going to look at is the for each loop. And this loop is used quite a lot. We use it when we want to loop over a collection. So we still did not learn about collections. We're going to have a separate lesson for this later on. A collection is basically some kind of data type that contains other data types. We can have a collection of strings. We can have a collection of integers. We can even have a collections of bools. And these collections can be arrays or lists, but we're going to get into the specifics in the actual lesson. For now, I just want to show you how we can use this for each, and we are also going to use it in the actual lesson, so don't worry if you still don't understand everything because you don't know what a collection is. A collection can be, let's say, an array of strings. So usually if we want to create a string, we basically have a string, and then we give it a name for the string, and we have a value. So this is the type, it's a string, this is the name of the variable, and this is the value of the variable. But if we want to create an array of strings, we simply add these brackets here at the beginning, and then the code will know that it's an array. So we can say my Pokemon collection. And then we create this array by using these brackets, and we can put strings inside. So Charmander, Bulbasaur, and Squirtle. Actually, Squirtle, like that. So we have an array of strings, and this is the name of the array. And then inside we have 3 different Pokemon, and each one is basically just a string. So it's a collection of strings. Obviously, we can do the same thing with integers. We can have an array of integers. Maybe we have grades for school. So it's basically the same thing, but this is an array of strings, and this is an array of integers. And we have the integers inside separated by these commas, or strings separated by commas. So again, this is not a lesson about arrays and collections, because we also have lists, and we create lists in a different way, and we have other things that we can do with it. But to understand the for each loop, we can simply loop over all of these elements inside of the array. So instead of just, let's say, printing this collection manually, console and then we can use this collection, and then we can basically access these elements by using these brackets and providing the index. We're going to talk about all of this in the actual lesson when we learn about collections, but just know that we can access each one of these elements by using these brackets and providing the index. So in coding, the first index is 0, and this is 1, and this is 2. So for example, I want to print Charmander, then I'm going to use the name of this array, and then I'm going to use these brackets, and I'm going to use index 0 because Charmander is the first one. So it's going to print, this is my Pokemon, and then it's going to print Charmander. And you can see it over here, this is my Pokemon, Charmander, okay? So this way we can print all of them, but we don't want to go and start printing all of these Pokemon and then go to Bulbasaur, index 1, and Squirtle, index 2. We don't want to do this, especially because we can have 100 different Pokemon inside of this array. So with this for each loop, we can loop over all of this collection and do different things. And to do this, we simply type in for each. So this is the way we create this kind of loop. We have these parentheses, and to loop over a certain data type, we need to provide the data type. So in our case, it's a string. Although this is an array of strings, each one of these is a string. So we say that we want to display a string. Then we give some kind of name. Again, it can be name, it can be Pokemon. This is just a variable name. It doesn't really matter. It can be maybe item, it can be whatever you want. This is not the important part. And then we use this in keyword, and we provide the actual array. So what will happen here? It will basically loop for each name of type string, because these ones are strings, in Pokemon collection. Now if we want to do this for the grades, we're simply going to say int, right? Because each one inside is an integer. For each integer, let's say number, in grades, we're going to loop. And it's going to loop each one of these. We can add any code and it will repeat the code, and we can also use this actual variable to do things with it. So in our case, we want to print each one of these. So we can say console write line. This is my Pokemon, and we're simply going to use the name. So we don't need to access this array and then provide the index. We simply provide the name that is being looped. And the same thing here, we can print each one of these grades. So this will print each one of the grades, and this will print each one of the Pokemon. And you can see, this is my Pokemon Charmander, this is my Pokemon Bulbasaur, Squirtle, grade 95, 185. Because this is what we did here. Obviously, we can add more code and do more things inside, but we use for each loops when we want to do something with these elements, right? We don't just use this for each loop in any case. We use this when we want to do something with this collection, with these elements, when we want to get the data inside. So that's the point of for each loops. The next thing I want to talk about is related to loops, but it is not only used in loops. And these are the break, continue, and return keywords. And we saw the break keyword in the switch statement that we used in the previous lesson. And we know that we use break to basically break out of the switch. But we can also use breaks to break out of a loop. For example, if we have a for loop, int I, as long as I is smaller than 10, then increase I. And then inside we can check if I is bigger than 5, then simply, first of all, print and break. So it will basically start looping over each number, right? We learned that it's going to loop the first time, it's going to increase I, and it's going to become 2. Then it's going to see that it's still smaller than 10. It's going to loop again. But here it will also check if I is bigger than 5. So the first few times, it's not going to be bigger than 5, right? It's going to be 1, it's going to be 2, it's going to be 3. Only when it reaches 6, then it's going to be bigger than 5, and then we're going to run this block, and we're going to print this, but we're also going to break. And it's not going to continue looping to 7, 8, 9, 10. Because we use this break, it will simply break, and it will end this loop, and it will continue here. So it will only run this once, and then it's going to exit this entire loop, and it will basically stop looping. So we can see it over here. It only printed this once. This is greater than 5. Of course, it should be I. So we can see this is greater than 5, 6, because 6 is greater than 5, but then it's not going to continue to 7, 8, 9, 10, although it should loop. But we use this break, and it means that it will basically break this loop and continue with the rest of the program. And this is basically the same thing it does inside of the switch. It breaks out of the switch. So if you see this sometimes, you know that it basically means that we found whatever we wanted and we broke out of the loop. Obviously, this can also be used in different types of loops. For example, the for each loop. Maybe we have this for each. Let's just go back. Maybe we have this for each loop that loops over all the Pokemon, and then I can say if name, which is these strings over here, equals Charmander, or maybe Bulbasaur, then we can print something. Let's also remove this. So with this, it will loop over this entire collection, and imagine we have hundreds of Pokemon inside. It will check this Pokemon each time, and if the name is Bulbasaur, it's going to print this. Bulbasaur. It's going to print this, but it's also going to break. And it means that it's not going to continue with Squirtle or the rest of the collection. It will simply stop this, and it will print something like okay, so now if we run this, it will simply say Bulbasaur found, loop ended. Or maybe we can also type something like this. Found name. And then it's going to print found Bulbasaur, found Charmander, and found Bulbasaur. But when Bulbasaur is found, then the loop will be ended, and we're not going to even find Squirtle, right? Because we broke out of this when we found Bulbasaur, so the loop did not continue on to Squirtle. So that's the point of breaking. Now continue does something very similar, but it basically tells us to continue to the next loop without running the rest of the code. So maybe we have something like this. Maybe we want to print all the names of the different Pokemon, but not Bulbasaur, right? We want to print Charmander, we want to print Squirtle, but when we reach and find Bulbasaur, we're simply going to continue to the next loop and we're not going to print it. So we're going to check this. And now you can see it found Charmander, right? It printed Charmander. Then it continued to the next loop. It found Bulbasaur, but because we have this continue, we're going to basically ignore the rest of this loop and we're going to start the next loop, which is going to find Squirtle and eventually it's going to end. So break breaks out of the loop entirely and it stops looping and continues on. Continue basically exits this iteration of the loop and ignores everything that comes after and just starts the next loop. Now, return is something that is mainly used in methods, and we're going to get to this later on in this course, but just know that return basically exits the entire method, and if you don't have a method, if you just have a class or something like that, it will basically end the entire process. So it will not continue with the code, it will basically stop it over here. Now we also have return to return a value, and sometimes we can return without a value and sometimes we can return with a value, but all of this will be relevant when we learn about methods. We can return true or we can return a value. Obviously here it's not going to work because it's not a method, but just know that if we see return, then it means that we should stop whatever is happening and we are not going to continue with the code. We're basically going to exit the entire method or the entire class. So we're going to learn about this more when we learn about methods. So these are the three things that we use inside loops and inside conditional logic. So we have break, continue, and return. And we also have the different types of loops that we learned: for, while, do while, and for each. And you just use them when you need to do something specific, when you need to have a known amount of loops. Loop as long as condition is true. Loop once and then check condition and continue looping. For each, loop over a collection. So this lesson was a bit longer, and that's just because we had a lot to cover. And I hope you learned something. And again, don't feel bad if you still struggle to understand some of these. Some of these can be tricky, especially the for one with the weird syntax. But don't worry, we're going to do this over and over again. And eventually you're going to learn, especially when you start dealing with actual code, when you start to write your own code, you're going to understand all of this. And you simply need to use whatever fits your use case. So thank you for watching. Please subscribe if you're still not a subscriber. You can also leave a like, and I'll see you in the next lesson.